Hello grade 12s. Welcome to revision on grade 11 statistics. So when we do grade 11 statistics revision, please remember there are certain things you have to know, like how to calculate the mean of a discrete data set, how to calculate the standard deviation of a discrete data set. So in order to do this, I'm going to do an example. And in this particular example, they've given us the data below shows the number of people visiting a local clinic per day to be vaccinated against measles. Now, this is a discrete data set because the data has not been divided into intervals or classes or groups. The data is still in its original format and it's discrete because it's 5 or 12 or 19 or 29. Okay. Now, the first question here, determine the mean of the given data, and then the second question, calculate the standard deviation. We generally use our calculator to do that for us. So to save some time, I've already entered the data over there. Just to remind you again on how to enter the data, you have to press Shift, and then you have to press Mode, and then for this particular calculator, you have to press Mode 3 to get it into your stat mode. The other calculators might have a different mode for stat mode. So please remember Mode, and then whichever one's listed as stat mode, press that button. Now, they give you the opportunity to enter the data, which, like I've said, I've already done. Once the data has been entered, I press the AC button only once. That's to clear the screen, just to make sure I didn't clear the data. I then press Shift and then number 1, because above 1 it says Stat. So that's all your statistical operations. So I press 1 for Stat, and then I always press 4 for variance. So I press 4, and then over there I've got X bar, which hopefully you guys should know, is your symbol for the mean. And I've got sigma x, which is the symbol for standard deviation. So if I press 2 over there, I end up with x bar being 21,47. I'm going to round all of these off to 2 decimal places. So the mean of the given data is then 21,47. Then I can press the AC button again, and all the data is already there. I don't have to enter it again. Just search Shift, Stat, 4 for variance, and then I've got sigma x over there, which is my standard deviation, and that is then going to be equal to 7,81. Sorry about that. Right. Now the next question then asks, determine the number of people vaccinated against measles that lies within 1 standard deviation of the mean. Now, if you want to go within 1 standard deviation of the mean, please remember, people, that means 1 standard deviation up from the mean and 1 standard deviation down from the mean. So you have to please remember to do that. You have to go up and you have to go down. So what we generally do, and I've given you it on the notes over here, is you take X bar, or the mean, you subtract 1 standard deviation, which is then going to be the bottom boundary of within 1 standard deviation of the mean. And then you take X bar and you plus 1 standard deviation, that's going to be the upper boundary. So think of it as distance. Think about the distance from the mean anywhere is not allowed to be greater than 1 standard deviation. So from the mean you can go 1 down, but from the mean you can also go 1 up, and that is still within 1 standard deviation of the mean. So using the values that I've already calculated over here, I can then go and I can turn this back into computer mode, and I can say 21.47 minus that 1 standard deviation, which is 7.81. That's going to be equal to 13.66. So that's my bottom boundary. Any value greater than 13.66 will be within 1 standard deviation of the mean. And then if I change this to plus, then I've got 29.28. So any value less than 29.28 is going to be within 1 standard deviation of the mean. Now, I've gone and arranged the data that was given up here from smallest to biggest, just to make it a little bit easier to find all the values that lie within 1 standard deviation of the mean. So, can't be less than 13.66, which means these values are less than 13.66. These values are less than 13.66. Actually, 13 is also less than 13.66. So these 3 values are less than that 13.66. Then the values can't be greater than 29.28. So if I look at that, up to about here it's fine, but these values, 33, 35, 30, 37, is greater than that 29.28. So that means these values over here, which if you count them are 13 values, are going to be within 1 standard deviation of the mean. Because those 3 at the top and those 3 at the bottom, 6 values, are going to be inside 1 standard deviation to the mean. So that means they're going to be 13 values within that 1 standard deviation of the mean. Now, the next question, determine the interquartile range for the data and draw a box and whisker plot to represent the data, has everything to do over here with what we refer to as the 5-number summary and the box and whisker plot. So please remember, 5-number summary is your minimum, your maximum, your median, your lower quartile, and your upper quartile. So please remember, your median is the middlemost value when the data is arranged from smallest to biggest. So that means it's that value where half of the data, 50% of the data, is greater than the median, and 50% of the data is going to be less than the median. Whereas your Q1, your lower quartile, means 25% of the data is less than the lower quartile, 75% of the data is greater than the lower quartile. And your upper quartile is going to be the value where 25% of the data is greater than the upper quartile and 75% of the data is less than the upper quartile. Okay, so hopefully that's understood. So please remember, when I'm trying to find these values, I need to have that data arranged from smallest to biggest. So because I've already arranged this data from smallest to biggest, it's quite easy to do. You can then go and you can say there are 19 values over here. And it's quite useful if you want to use this formula to say 19 plus 1, which is 20, divided by 2 is going to be 10. Now that means the 10th value is going to be equal to my median. And that makes a lot of sense because if I have 19 data values like I have over here, you can split the 19 into 9 plus 9 plus 1. So 9 plus 9 is 18, and then plus 1 is the middlemost value, which then means the 10th value is the middlemost value. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right there, I've got my median. Now, if your median is a value on its own, then you ignore that value in the next calculation. Meaning when you want to get that lower quartile and the upper quartile, you ignore that value and you look at the 9 at the bottom. And then you ask yourself, can 9 be divided exactly the same way we did it now? Of course it can. 9 can be divided into 4 plus 1 plus 4. So 4 plus 1 plus 4 gives me the 9, which means my 5th value is going to be my lower quartile. 1, 2, 3, 4, 5. So that's going to be my lower quartile, Q1. And then same thing over here, because whatever you did in that bottom half of the data, you can do in the top half. So I can again go 1, 2, 3, 4, 5, and that's going to be my upper quartile. And just to check, always make sure that you have the same number of values between these. So you can count 1, 2, 3, 4, lower quartile, 1, 2, 3, 4, median, 1, 2, 3, 4, upper quartile, 1, 2, 3, 4. It's not always this easy. This was a fairly easy example, but please see if you can try and remember how to do these. Okay. Now, why did we do this? We did this to find, number one, the interquartile range. So my interquartile range is given over here. The interquartile range is going to be Q3 minus Q1, so the upper quartile minus the lower quartile. And that is then going to be 26 minus 18, which is going to be equal to 8. And then I can also use these values to go and draw my box and whisker plot. Please remember, my box and whisker plot consists of, and I've drawn it for you guys already over here, it consists of my minimum value 5, my maximum value 37, and then my lower quartile 18, my median, and my upper quartile. And please, please, people, remember, this must always be scaled. So there must always be a number line below it so that this is according to scale, so you can see whether the data is skewed to the left or skewed to the right. Now, skewed to the left or skewed to the right over here. Generally, if they're going to ask you a question about skew to the left or skew to the right, you will clearly see the skewness of the box and whisker plot. Like in this case, it's very clearly more spread out to the right, so it's skewed to the right, more spread out to the left, so it's skewed to the left. Or it's symmetrical, because it looks like the left and the right hand side are the same. If you're worried that you can't exactly see whether it's skewed to the left, skewed to the right, or symmetrical, you can go for the other definition. For data to be skewed to the right, x bar, the mean, must be greater than the median. For data to be skewed to the left, x bar, the mean, must be less than the median. And for data to be symmetrical, x bar must be equal to the median. So for this one, you can't actually very clearly see whether it's skewed to the left or skewed to the right. It's not very clear. But if they did go and ask you the question, you could then go and say, but we've already calculated x bar was 21,47. We already calculated the median was 21. So yes, x bar is slightly bigger than the median, so you can actually be forgiven for saying this data is skewed to the right. But you could also go and say it's symmetrical, because it is very, very, very close to each other. But I would prefer skewed to the right because x bar is greater than 21. Okay. Next question. Identify any outliers in the data set and substantiate your answer. So to identify outliers, we do have a formula, and that is right over here. A value is considered an outlier if the value is less than the lower quartile minus 1.5 times the IQR, then it'll be an outlier at the bottom, or the value is greater than the upper quartile plus 1.5 times the interquartile range. And then the data is considered to be an outlier at the top. So, because I've worked out the interquartile range over there, which is 8, and I know my lower quartile and my upper quartile from here, I can then go and say 18 minus 1.5 times 8 is going to be 6. And then over there, 26 plus 1.5 times 8 is going to be 38. And then looking at the data over here, I can clearly see 5 is going to be less than this value of 6. So 5 can be identified as an outlier at the bottom. But there's no value greater than 38, the biggest value being 37, so there's no outlier at the top. So therefore, you can then go and say 5 is an outlier. So this is looking at discrete data. This entire example was an example about discrete data. Please remember group data. For us to consider group data, generally what we say is we say it must be divided into classes or intervals. So we're going to look at an example of grouped data just now. Okay, so when talking about group data, we have classes or we have intervals. And one of the most important things you need to be able to do here, you need to be able to draw an ogive or cumulative frequency curve. So please remember, an ogive or cumulative frequency curve, the coordinates that we use over here to plot the data is we plot every single time the end of the class and the cumulative frequency. Except for the very first point, it's the beginning of the first class and 0. So in this particular example that they've got over here, they gave you a histogram saying a group of grade 11 learners were interviewed about using a certain application to send SMS messages. Sorry, that's a bit better. The number of SMS messages M sent by each learner was summarized in the histogram. So they give you your classes 0 to 2, 2 to 4, 4 to 6, and they give you your frequency for each of these classes. Now they ask, complete the cumulative frequency table provided in diagram sheet 1, which I've already done over here. So pretty much I just transferred the frequency of each one of these bars in the histogram. I've transferred that. And then to get the cumulative frequency, you guys should know this by now, 7 gets transferred, 7 plus 15 is 22, 22 plus 26 is 48, 48 plus 29 is 77, and so forth. And then to talk about the ogive or the cumulative frequency diagram, remember the first point is going to be the first value of the class, in this case 0 and 0. So it's going to be the point 0, 0. These points are the important ones where you remember, do not use the middle of the classes. You use the end of the class. So you're going to use here the point 27 is the point you plot. Then you're going to plot the point 422. That's the point you plot. Then you're going to plot the point 648 and then 877. So you plot all of those points on the diagram and you draw a curve, not straight line. Please don't draw straight line, straight line, straight line. You draw a curve that I said looks a little bit like a brontosaurus, a vegisaurus. Okay, some people say it looks like an S. I think it looks a little bit more like a dinosaur. But you plot that. So that is then your ogive, or your cumulative frequency diagram. Now the ogive actually gives you quite a bit of information, specifically about the spread of the data. So you can use the ogive to calculate your median as well as your quartiles. And that is pretty easy and straightforward. If you want to go and use an ogive to use the quartiles, please remember to take the total frequency and divide it by 2 to know where the median is located, divide it by 4 to know where the lower quartile is located, and then multiply it by 3/4 to know where the upper quartile is located. So you'll see the total frequency here is 160. So you divide that in half. I go to 80, I go across, and I go down. And right over here, there, that's where my median is located. And then I can do the same thing for the quartiles. I take 80, I divide that in half, which means 40. I go down. So right over there, that's where my lower quartile is located. And then I can divide that in half, which is then going to be at 120. I go across and down. And that is then going to be where my upper quartile is located. And by the way, this is also how I can use my ogive to draw a box and whisker plot and look at how skewed the data is. So I can actually go and I can say, here's my box. And remember, this is already scaled. So this is absolutely fine. And then obviously it's going to go to my minimum over there, which is 0. And it's going to go to my maximum over there, which is at 16. So that actually gives me my box and whisker plot just by getting my quartile, my median, and my lower quartile, median, and upper quartile. So they asked, use the ogive to identify the median for the data. So I would say the median of the data here is probably about 8,2. So that's probably going to be about 8,2. And then estimate the percentage of learners who sent more than 11 messages using this application. Now this one goes a little bit the other direction because they wanted to know how many learners sent more than 11 messages. So I go to 11 over here, and instead of going from that side down, I go up. And across. And that looks to be about 131. So we know that 131 learners sent less than 11 messages. So this part right there are the learners that sent more than 11 messages. So I can go and say it's then 160 minus 131, which means 29. Around about 29 of the learners sent more than 11 messages. So if I want to know the percentage of learners who sent more, I can say it's 29 out of the 160 times 100 over 1 to get that percentage. And that is going to be around about 18.13%. It's not always exactly accurate, but obviously you want to try and make it as neat as possible. Now, the question, in which direction is the data skewed? Then obviously we can look at this and we can kind of judge by saying this, that length about, this one is slightly shorter. So looking at this, the data is skewed to the left. So the data here seems to be slightly skewed to the left. Again, not completely accurate, but they will give you the benefit of the doubt. Now please remember, just a quick heads up, if you do want to go and you want to go and calculate the actual median and you want to calculate the standard deviation on this data set, you have to remember to turn on the frequency of your calculator. So what I mean with that is I mean the following. You go and you press Shift, Setup, and then you scroll down. And then it asks you number 4 for stat, and you select that number 4 for stat, and it asks you frequency on or frequency off. And we turn the frequency on, we press number 1. Now, when I go to mode and I go to stat mode number 3 over here, and I select 1 for one variable, I have X and I have the frequency, because I need the frequency if I'm going to use something like this data where I've collected it on that frequency table. So when you want to get your mean and you want to get your standard deviation here, please remember in this case you have to use the midpoint of the classes. So I did write it over here as well. So when you do the mean and standard deviation for group data, please remember to use the midpoint of each class interval to represent X, and remember to switch the frequency on. So over here the midpoint is going to be 0 plus 2, which is 2 divided by 2 is 1, so the middle is 1. And then obviously the middle is going to be 3, 5, 7, 9, 11, 13, and 15. There you go. And then I can scroll up and I can just put the frequency there. So the frequency, not the cumulative frequency in this case, the frequency for each class. That's going to be 7, 15, 26, 29, 36, 31, 14, and 2. And then once that data is entered, you can press AC again, Shift, Stat, and then Variance again, and I can ask for that mean, which in this case is 7,8875. And I'm just going to write that down over here, because if we go back to the ogive that I drew over here, if you're not exactly comfortable saying that this is skewed to the left, you can then go and you can compare the mean, which is 7,8875, to the median, which is just greater than 8. So this mean is less than the median, which means this data is in fact skewed to the left, if you weren't completely comfortable with that. And you can then use this as well to get to your standard deviation. So that's pretty much the techniques and the skills you have to have for your grade 11 stats. Thank you so much for listening.